Everyone, and welcome to a video on fuels and combustion. Since the days when we were cavemen, humans have had this fascination with fire, and that's not hard to believe. I mean, fire keeps us warm when it's cold, and fire illuminates the darkness around us, especially in those days when there were all sorts of creatures and predators stalking us in the dark. Fire allowed us to see them coming and protect ourselves from them. But how does it work? How does something burn? Well, to answer that question, we first need to look at a fuel. What are fuels? Fuels are materials that can burn to release the energy stored inside of it. So, examples of fuels are materials like wood or products made from wood, like, furniture, for example. Other examples of fuels are sugar, right? This is one type of sugar, but sugars in general are fuels, and they're the fuels for living things. And then we get petroleum or petrol that is made from fossil fuels. Um, but more of that in another video. So, how do fuels release their energy? So, fuels have a potential energy inside of them called chemical energy. And that energy is stored in the bonds that exist between the atoms that make up the fuel molecules. So, this is a particular molecule. This molecule is called methane, right? And methane is a gas, and it is made up of one carbon atom and let's use orange, four hydrogen atoms. Right, there's three, and the fourth one is at the back there, right? So that's methane, and the way it works or how it releases this energy is when these bonds are broken, right? Uh, this causes, or to break the bonds, first of all, you need energy. But in a fuel, you need way less energy to break the bonds than the energy that's released once those bonds are broken and new bonds form. So if we look at if I show you like what happens chemically, you'll get your CH4, your methane, right? You add a little bit of heat just to break the bonds, and there must be oxygen. So if that happens and there's oxygen present, this causes what we call a combustion reaction, right? So this causes a combustion reaction. That's combustion, which then releases more heat, right, or thermal energy, plus it releases light. So when a fire burns, you'll notice that there's light from the fire and it's warm, right? That's the heat and the light. Plus carbon dioxide, which is a gas, and then plus water, which many people don't actually realize happens when something burns, that it actually makes water. And that's a hard, or that's like counterintuitive, because you think, well, surely when something burns, water doesn't come from it, but strangely it does. So when carbon dioxide and water form from the breaking of these bonds, the energy that they release when they form is much more than the energy that you needed to break these bonds in the first place. And that's how a fuel works. Because fuels burn so easily, they need way less energy to get them to burn than the energy they release once they burn. So let's take a look at what is combustion, right? By definition. So put simply, it's when a fuel burns, and that's what it is. And if I go further into it, it's a chemical reaction that happens when a fuel reacts with oxygen. So combustion cannot happen if there is no oxygen present. There has to be oxygen, and then a fuel can combust, right? The oxygen reacts with the atoms, and with the thermal energy breaking those bonds, new bonds can form with oxygen being there. So that and that causes energy to be released. So a combustion reaction will always produce lots of thermal energy and light, right? Example, if you think of any fire, right, that happens. And as well as carbon dioxide gas and water. you can actually see this happen. If you ever look at a fire, you'll see that there's a weird shimmer of the air right above the flame, and that's actually the gases of carbon dioxide and water coming out from the combustion reaction, causing light to bend at that position. And the effect you see with your eyes is it almost looks like the air is bending a little, but that's just because the light is bending through a different concentration of gases at that point. So the way let's look at a combustion reaction as a whole now. So for any combustion reaction to occur, you first need a fuel, which is rich in chemical energy, right? So it has chemical energy just waiting to be tapped into and released as heat and light. And then when I add thermal energy and oxygen, and if there's oxygen available, then next thing you know, I have a combustion reaction. Then once I have the fuel, the thermal energy, and the oxygen, combustion can take place, and so my wood will catch on fire and will begin to burn. And this burning of the wood is the combustion reaction. You're actually seeing a chemical reaction take place. So when you see something burn, you're actually seeing a chemical reaction, which is cool because you don't always see chemical reactions. But what makes this one so visible is the fact that it releases so much light, and it produces heat. So it's easy to perceive this chemical reaction in a physical way. And then you have thermal energy. So from that chemical reaction, from combustion, you have thermal energy, you have light energy, you have water, and you have carbon dioxide being released. So there's our water molecule, our H2O, right? There's H2O, and then that was terrible. Okay, so there's H2O, and we have our carbon dioxide, which is CO2. Right, and then along with energies like your light energy, your thermal energy and your light energy. Okay, and that is combustion. Like, your chemists already, you're looking at chemical reactions, and you were doing it for a long time, you just didn't know it. Okay, so here's just one last look at combustion as a holistic picture. So you'll see here it says CH hydrocarbon, right? This is just basically they saying this is a fuel, because most fuels have a CH or hydrocarbon bond, meaning there's a carbon somewhere and there's a hydrogen attached to that carbon. So most fuels will have that sort of molecular structure. That's why they're saying hydrocarbon. So don't worry too much about that. You don't even have to know that word. Plus O2, which is essential for a combustion reaction to occur. They don't even add the thermal energy because in so many cases you need so little thermal energy that it's sometimes ignored. But please add thermal energy as well, because the bonds need to be broken first, and for that to happen, there must be thermal energy for that to take place. So we'll have the fuel, we have our oxygen, we have the thermal energy, then we have our combustion, right? This arrow shows combustion, which releases carbon dioxide and water, plus it releases light and heat that you get from the fire. And by the way, the smoke is actually a combination of the ashes from the burning material plus carbon dioxide plus water, right? And yeah, that's what smoke is, and that's what the vapors or the gases coming from the fire are. So that the ashes part, or the white part of the smoke, is actually ashes. You can't see the water and you cannot see the carbon dioxide, but they're still there. And you'll see here that for a combustion reaction to be sustained, that means for it to keep going, you need to keep having oxygen supplied to the reaction. Otherwise, if you have oxygen in the beginning, you can start it, but once you remove the oxygen, it will stop because the oxygen keeps the reaction going. All right, so I hope that you found that helpful, and like always, drop a like, drop a subscribe if you haven't subscribed already, because more videos are coming, and like always, I'm here to to teach you, and you learn things that you might never thought you never knew, and you never thought was like you never thought existed, or you never know what you could learn. Never stop learning. Keep stay awesome. Till next time.